Well before now, you've learned that you can solve quadratic equations, even though we may not have used the vocabulary necessarily before today. A quadratic equation is one that has a power of 2, or its degree, the degree of the equation is 2. And so with one like this, you found that there's a couple of different ways you can solve it. One way is, since both of these are perfect squares, you can add 25 to both sides of the equation and say that x squared is equal to 25. Then you can take the square root of both sides. So x then would be equal to plus or minus 5. That was part of our understanding, because because of the other way that you could solve this. You could also solve this by factoring and using the zero product principle, which is to say that this is the difference of two squares, so its factors are conjugates, x plus 5 times x minus 5, and that's equals 0. And the zero product principle says that if a or b, if a times b is equal to 0, then either a or b is 0. So x plus 5 equals 0, or x minus 5 equals 0. In this case, x would be negative 5. In this case, x would be 5. So we've learned how to do that, right? And this factoring's really helped us out, whether we've had to factor two binomials or factor something that looks like 6x squared minus 15x equals 0. Well, this one we can just as easily factor because it's got a greatest common factor between 6x squared and 15x. That would be 3x, right? And so when I divide out 3x from both of these terms, I get that 3x times, let's see, 2, so that'll be 2x, that'll give me the squared there, and minus 5, and my x's cancel, and that's what's equal to 0. So that means that either 3x is equal to 0 or 2x minus 5 is equal to 0. And here we just divide both sides by 3. Doesn't matter, x would still be 0. Or here we would have that x is equal to positive 5 halves. But what does it mean when we set our quadratic equations equal to 0 and then we solve for them? Let's take a look at what the practical value of that is. Let's take a look at this equation here, and we'll say that we have the function f of x is equal to x squared minus 25, and what we do is we set that equal to 0, as we've done here, and solve for x, and we get that x is equal to negative 5 and x is equal to 5. Well, the function f of x is equal to x squared minus 25 means essentially this. We'll use GeoGebra here, and what we found are the roots of the function. Let's see what that means. So to graph x squared, or y, is equal to x squared minus 25, we have the graph of a parabola. You can tell it's a parabola because it's got a minimum point, because x squared is positive. It's got a minimum point, and from that minimum point it goes up in both directions. And now we have two very special points here. They are here at negative 5, 0, and here at 5, 0. These points are called roots. Here and here. And these are the points that our graph will cross the x-axis. They are x-intercepts, so to speak. So the basics of solving quadratic equations is that we solve them by setting them equal to 0 and then finding out what x must be in order for the equation to equal 0. With the quadratic, you will have up to 2 points where x is equal to 0. In this case, it was negative 5 and 0, and in the other case, it was 5 and 0. And those are called the roots of the equation.